So let's look at the formula and the parts of an ellipse in a little more detail. So on this slide, we can see that both of these ellipses have the same equation right here, which when they're centered at the origin, this is what it is. Notice that the standard form for an ellipse always equals 1. So that's going to be important when we do our practice problems. So if A is bigger than B, remember A is always going to be the horizontal distance measured from the ellipse to the center, and B is always going to be the vertical distance measured from the ellipse to the center. So if A is bigger than B, it's going to be stretched more horizontally. But if A is less than B, then it's going to be stretched less horizontally than vertically. It's going to be a vertical ellipse. So the pink points on both of these are called vertices. Vertices always go along the longest distance. So if it's a horizontal ellipse, then the vertices are aligned horizontally from each other. But if it's a vertical ellipse, then the vertices are going to be vertical from each other. And then the other 2 points are called the co-vertices. Some people call these the vertices also, but if you ever hear the term co-vertices, it's specifically these points that are along the shorter distance. And again, if it's a horizontal ellipse, then the co-vertices are going to be vertical from each other. But if it's a vertical ellipse, then the co-vertices are going to be horizontal from each other. And then finally we don't have a diameter for an ellipse because it doesn't have the same diameter all the way around, but this longest distance is called the major axis, and the shortest distance is called the minor axis. So the major axis is horizontal on a horizontal ellipse, but the major axis is going to be vertical on a vertical ellipse. And then accordingly, the length of the major axis on a horizontal ellipse is going to be 2a, but on a vertical ellipse is 2b, because on the horizontal ellipse we're measuring horizontally, and on the vertical ellipse we're measuring vertically. And then the length of the minor axis is going to be 2b or 2a, depending on how the ellipse is aligned. So that's kind of a rundown of the parts. The other thing that's important here is these formulas. And just remember, it's similar to the Pythagorean theorem. However, just keep in mind that you're always going to have to add up to the biggest distance. So between A, B, and C on a horizontal ellipse, A is going to be the biggest distance. So these things have to add up to A squared. So B squared plus C squared is A squared. But on a vertical ellipse, B is the biggest. So it's going to be A squared plus C squared equals B squared. So just always remember you're going to add up to the biggest, and it's easy to remember these formulas here. So let's look at moving off now. Oh, actually, before we do that, let's just look. This right here just goes a little more in, it describes the vocabulary a little more. But now we're putting the center off of the origin. So the center is no longer at 0, 0. It's going to be at HK. But again, I just picked a horizontal ellipse here to align the ellipse. So the vertices are going to be along the longer distance. But again, remember, we could rotate this picture 90 degrees and make it a vertical ellipse. And then the vertices are going to be up and down from each other. But we have the major axis. This gives the definition. We have the minor axis. It gives the definition. And then just a little note here too about vocabulary. So we have one focus, but if you have more than one focus, we call them foci. If you have more than one vertex, we call them vertices. And then if we shift the whole thing, h units horizontally and k units vertically, there's that x minus h, y minus k that we see all the time. So this is a good reference if you want the vocabulary. And then finally, this is another way to think about it for those people that think more numerically. But again, also just try to think of the whole thing conceptually. So here we have a horizontal ellipse. So the foci are going to be arranged horizontally from each other. So we have the center at HK, and then A is always going to be your horizontal distance from the center. So if we're going to go A units to the right, Now we're going to be at h plus a for this vertex. And if we go h units to the left, we're going to have to subtract a. And then if we look at b, remember b is going to be the vertical distance. So from k, you're either going to add b or subtract b. And then in this case, because we are talking a horizontal ellipse, then c is measured horizontally. And so we're still adding or subtracting from the x coordinate. But if we have a vertical ellipse, really the only thing that changes in this picture is really the c, because now the foci are going to have to go up and down from each other. But we still have the covertices here, but we're still going to subtract a and add a, because now they're horizontally. The vertices are going to be vertically aligned, so we're going to add and subtract b from the y coordinate, and now we're adding and subtracting c from the y coordinate. So just some things to think about. All right, so that's it for the formulas, and then the last video is going to be just some practice problems.